welcome everyone to this talk, which is Lens Integration with Apache Iceberg, the latest progress. So about 6 months ago, I made a talk exactly the same title, Lens Integration with Apache Iceberg, that with essentially no progress. Everything is just vision. And 6 months later, we have made a lot of progress. I think everyone is very excited about integrating Lens, which is a new format for machine learning and large language models with Iceberg. And we have seen lots of activities in open source. So a little bit about me before we get started. I'm Jack. I work for LensDB, and I'm a Apache Iceberg PhD member, Polaris TPMC member, Lens maintain, and contributing to a few open source projects. And before LensDB, I'm a engineer in Amazon. So I was a tech lead for a few integrations with open table formats, EM and Athena, and led the SageMaker Lakehouse effort and S3 tables effort. And today's agenda is very simple. We'll talk about what we have talked about in the springtime, about the background, what is Lens, the file format, the table format, the catalog, and then the latest progress about how that has been evolved to facilitate and enable this integration. First of all, for people who don't know Lens, what is Lens and why yet another format? See, this all goes into the so-called multimodal AI challenge that we are facing right now today as the whole AI wave is going on. So multimodal data is usually much bigger than the tabular data. So even when you store data in Iceberg, if you have like a petabyte table, that is already a huge table, because everything in the world is just that small. However, when you add embeddings, which is roughly 4 kilobytes per row, data is 25 times bigger. And if you add image and videos, then the whole table just explodes. And there are different ways to tackle that, but more than ideal, we are just really working around the system at this point. And we believe there's a better solution that can be made to better fit this multimodal AI age. And this is really the whole vision we are looking towards here, that if you look into this graph and you are coming from the warehouse world, you will see this very familiar, because 10 years ago, this is literally the left side is the data warehouse and the right side is data lake. That there are dedicated solutions that you have to build, and there are data silos in order for you to use different solutions once your data is in the data warehouse. And then you move to architecture that data is in a data lake with open table formats like Iceberg, and you can do whatever analytic engines, BI engines on top of that. However, when going to the ML world, it's kind of still, so we haven't really fully finished the forward yet, because when you want to do a full text search, you have to still load data into Elasticsearch for good performance. When you want to do actually search, you still have to choose all these different vector database products, and that was still creating data silos through and what we envision is that there's a tree vision of multimodal lakehouse, what we call that there's an open format that can back this. It can be multiple open formats, but there's an open solution that data set in one single solution, and different engines can fulfill all the AI and ML workloads. And that is what Lens is trying to enable here. And here's probably a more concept graph for what we are talking about here. For example, there is this table, which is a Lens dataset. It has YAML tabular columns like ins, tags, and floats. And you can do YAML SQL queries on top of that. There's syntax search columns that are very long text that are generated by captioning services, generated by large language models. You can do full text search on that. And there are vectors, different, again, generated by different embedding products that you can do vector search on that. And you can have research all those together using a single storage solution that is open. That is what we are talking about here. And I think Lens, Lens is a file format and a table format. So for the file format side, it is calling a format that is more optimized for random access comparing to Iceberg, that is Iceberg Parquet, that is more optimized for overlap and scaling purposes. So lots of the efforts are built into optimizing random access performance so that it can be better served for search workloads like vector search and full text search. And the table format is kind of similar to Iceberg, actually listening to data lake. And there are some native features such as two-dimensional storage, zero copy data evaluation that are more oriented for machine learning and AI use cases. So today, Lens is already, I think, quite popular. We are the most trending format in the whole format domain. And there are all these companies that are using that. We have a good selection of companies that are building their own data lake solutions for AI purposes. We have different data info vendors that are using that. And there are different frontier model companies like WorldLab, Runway, Curtain AI, all these companies that are using it. So we have a very vibrant community for the ML AI world that are building the solution together. So for the platform case, as I said, the goal is for fast random access. And our what we have achieved is that there's only one error if we are doing a fixed size a search for the fixed size field, such as a fixed size vector. And there are 2 errors really for any other random access situation for variable size data types. And one big thing we have removed is the row group, because when we are storing multimodal data, when we are storing very big images, very big videos into the data, or the format that Apache or Apache and log, specifically, they have the concept of row groups, and that is really bad for performance because either way it is too big or too small, and both are not good for burst rate, right? And so just remove the groups so that when you write, you just drop in the data pages. And in the end, you still have the calling the data flavor, but there's no alignment inside the row group so that it's a much faster write, and then you can do much faster random access because of that. And then we do the alignment at the table format level. I will talk into that a bit more. This is, if you want to know the details, this is what we did in RealDB. This is the author, rest in peace. He's wearing the our welcome can see Heinz's t-shirts. There is a paper we presented about this idea. And another feature that we added in the file format is really pluggable encoding to support your different kinds of multimodal data. And today, the most commonly used one is what we call the blob encoding. So that when you're storing a blob data, that is not still directly in the data pages, but it is maybe stored out of line. So it is still in a single file, but it doesn't have to be aligned into the page. And in the page, you always store the data about the position and index of the image so that it can be used for very fast retrieval. And this is very beneficial and very important for use cases such as you are putting an image into the GPU to do any sort of training. By doing this, you can actually pull images in a much faster way and doing the access in a much faster way as well. And then the table format, as I said, this is more closer to Data Lake than Iceberg, but the goal is really to build a same kind of transactionality on top of that, and on top of the file format. And what we realized is that in order to better serve the workflows like vector search and free text search, index is very important. So we made index really a first class in the format. The index itself, if you look into the documentation, it's almost its own stack. So there's the index stack within the table format stack. So the index files are a part of the central ecosystem. And the other thing we did is the fragments. The fragments is kind of similar to data files in Iceberg with Delta. And the key difference is that, for example, we can see the graph here. We can store different data of different columns to different files. And these files are also less files, by the way. And then by doing that, you can have some good features for ML training I will talk about later. I'm going back to the index part. So as I said, everything is based on stack, and everything is stored as nice files. So the index, in the end, they are just mapping of the values to raw address, but there are different index for different purposes. For example, for vectors, there are all these fancy IVF, PQ, SQ, and the ST-Flash, HSW. All these kind of things are part of the spec. And there are also index like free text search index, scalar index like B-tree, bitmap, labor list, map, feature. All these kind of indexes are over there. And for data evolution, that is what I was talking about the fragment. Because we store different columns even fast, it becomes very easy to do what we call data evolution. So if you're familiar with Iceberg, you know that Iceberg can do scalar evolution. So when you add a column, for example, then all your new data comes with new column added. And the existing data can still be queried. The field will just be showing now. However, when you do that in ML world, like if you add a column, most likely you are adding a feature, right? And if you add a feature, then most likely you have to backfill all the existing columns. And if you do that in Iceberg, then you have to rewrite the whole table essentially, because all the files, all the data files are containing all the columns. So there's really no way you can avoid of data rewrite. And in this case, if you are doing less, then you can really just write all the new data as a new file. And essentially, as I showed here, you are essentially just appending new files as new columns. So that is what we call data evolution, which is data initiation plus backfill in a much faster way. So, for example, here is an example of our customer like Runway. They use this very extensively. So you can really start with, for example, an image column, And all the rectangles you see here are just new columns they keep adding, right? So you keep having different transformations. Either it is single transformation, like a Python function where you go through the GPU to all the large language models. All these new things, new features are just new columns. So that makes the cleaning much faster and much more convenient. And the last thing about the catalog is what a new component we added. I think I also talk about that in the last talk, which is left namespace to standardize the lakehouse reactions. So on the left side, you have the catalog, meta lake, whatever you call that. And on the right side, you have different engines like Spark, Flake, Trio, Kafka, Ray. And they all speak, for the last word, you speak through this last learning interface, which is connected to the Iceberg catalog interface. I guess the key difference is that because we have to support a flat directional series, which is for some reason machine learning engineers really like that. That is why it's called namespace, because it can just contain tables. And one segment for people who, I think this is a question we frequently get asked. I will just put it here: that what is different between Elastic and SDB? First, there's the LastDB company, but there's also the LastDB open source project. So we talk about the Last format. And then if we go to the LastDB, the Last GitHub repo, that is containing the Last SDKs, you can provide storage, query, like maintenance functions on top of the format. It's essentially implementation. And it is a Rust implementation with binaries in Python, Java, different languages. On top of that, the thing between Last SDK and the LastDB SDK is that the LastDB is very purpose-built for machine learning engineers and AI scientists. So that that contains all the AI integrations with like LangChain, Llama Index, OpenAI, Gemini, all these kind of AI integrations are in the LastDB world. But if you are coming from a data ether background, like you're into a Spark with Last, and that is where you use the Last SDK. Yeah. And then there's the LastDB company, of course, for cloud enterprise use cases. So after the introduction, then we can get into the new things, the last equation is Iceberg. So as I said, there has been a lot of community interest after the initial talk in spring, and the investigation has been going on. I will still separate into the file format, table format, and catalog to talk about what has been added. So the first thing, I think initially there was the proposal, I think it was in the Iceberg Summit 2025 that Microsoft co-presented with us about a proposal in Iceberg to support multiple file formats, so that the Iceberg can be adopted to multiple file formats. And the conclusion with Lens at that point was that Lens wasn't pretty, like the benefit wasn't really huge if you integrate with Lens, because as I was talking about, many of the features such as vector search, these are on the table format level. So the benefit is limited, but the community is actually exploring one year about what exactly the use cases are. And actually, I think we found two very good ones. The first one is where to store multiple data, for example, images and videos. I think someone did like a benchmark. You just store the data you like, so you use the POC integration we did, and you get much better performance for reading data compared to storing that in Parquet. Like there are a few different configurations they tested. And also, even with the file format, it has showed much better random access performance. So that is also one thing that people started to get more and more interested to actually use integration. Currently, there are a few of these that are testing that in their production environment. So we should expect more coming into the Iceberg community after the integration has been more maturely tested. Also, I found quite a few gaps that we have filled. Because when we did the integration, it was the format 2.0, and we kind of incorporated all the feedbacks so that we just released a 2.1 with those feedback. The biggest one is that people try to compare that with Parquet, and if you use 2.0, then you see that the compression ratio is really bad. Of course, the biggest reason is that Lens is optimized for random access, and compression kind of hurts that. So we don't do as strong compression as Parquet do by default. However, I think we have filled in all the gaps so far in the 2.1, so that by default, of course, you are not going to get that. But if you want to have a closer to Parquet storage performance, so that if you are caring about storage cost or you want to get a closer to Parquet kind of experience, you can actually tune in other knobs to achieve that. So for example, these are the knobs you can tune. Because Linux uses the arrow schema directly. So like this is how you specify the arrow schema. You just specify that we say additional last net data, and everything will be able to support the additional compression and encoding, so that if you want to make that closer to 5K, you can do that now. Yeah. And then the second part is how can we really get the most benefits out of Lens? Like, I say using as two friend with Iceberg, which seems wrong, but so can I use my two friend with another? But that goes back to like just recap their vision I was talking about previously. So the segments really maps to data files, and what we really want to do is not really integrate with the Lens file format, but integrate the fragment. And once the fragment, it's not just a fragment because there are also the index files. So you really want to index the fragment past the index files to get the most out of the integration, right? And so that is kind of what we have moved towards. Which this is also a slide I showed previously, which is if we do the integration like trying to integrate Lens into Iceberg, what would that really look like in the ideal case, which is you have the Iceberg catalog, which has the arrow manifests, and that points to the fragments. That actually points to the fragments. These are data files in Lens, and then because you are pointing to the fragment, you can kind of derive what are the index files, and then you can use that for queries if you need. And actually there are people who are kind of actively exploring that. That's right. And one of the way this is actually purely community contributions for that, which is we added the zoom map index and beam filter index so that the data is much more closer to how the Parquet look like. If you are comparing a Lens fragment now, it will be much more closer to Parquet than it used to be. Because before that, there were only like B-tree index, bitmap index. Those are what I call exact indexes. So when we link into the index, you want to know exactly which row to query based on the index. That is very good for random access for Lens, but pretty bad for if you are using the Iceberg. But zoom map index, that is essentially similar to the index stats in the Iceberg manifest and in the Parquet climate group stats. And beam filter is also present in Parquet, so for people who are familiar with. So these are essentially concepts that are present in Parquet that are good for lab use cases that we have added to, the community users have added to facilitate this integration. So it kind of fills in the gap for the lab use cases and makes the fragment much closer to a Parquet file. And actually that has to apply to, for example, query execution. So the query execution now also is much closer to what Iceberg and Delta is doing well. So for example, this is like what we do before. It's actually quite different file, but this is in Spark, and it's actually quite different from Iceberg Delta lot. So what we do is we distribute those fragments directly, and then the execution, that is where the pruning happens with all the indexes. And then that goes into the arrow local batches to the vectorized calling batch. However, so you can imagine that there are slightly wasted efforts because some fragments cannot be scanned anyway. And the zoom map index here is that there's a lot of this prefetching that is happening in the driver that is done before the fragments or the zones are sent to the executors to be executed. So that makes the integration much more smooth. Okay, so the last one is about using Lens tables in Aspect catalog. That goes back to the catalog integration I was talking about. And we have tested, actually this is the one that I think most of the customers are currently the most interested in. So over the course of the past 6 months, we have essentially filled in the gap with most of the integrations, I think, with the major catalogs. Starting from the most basic high listener to the ones people use today, Polaris, Gravity, or Unity, all the commercial solutions like AWS Glue. So today you can essentially store Iceberg and Lens into a same catalog. And there are some customers that are very actively testing the REST standard with us. And so there's also a REST standard developed in Lens, similar to the Iceberg REST catalog. So that it is, I think, since most of the companies who has a data interactivity and will like this solution because they already have all the REST APIs for Iceberg, and they just add additional REST APIs for Lens. And this is really facilitating adoptions as we see. So people who are using Iceberg, and they are essentially now using Iceberg for BI and Iceberg AI. That's the nice way to put it. And and also the APIs, the REST APIs, we provide a very wide range of APIs. So either the country wants to do just minimal integrations, then I think there you just implement like 7 APIs. Yeah. And if you want to do more, then there are like 26 unique flags you can do. Yeah. And I'm always even more excited that we have also the lineage. I think the last time case of our lineage stuff, and inside Spark. So most of the lineage, so you can do actually lineage with CDC, and that automatically happens if you use an SSDK, which knows all the addresses. So that you can derive CDC or change the string from lines, and then you can write that into Iceberg, or vice versa. I think that also works. So that you can essentially have this two table state that are in sync with each other. So that seems to be what most of the companies that not exploring the format side of the integration are exploring, which is like this two table state. Yeah. And in the end, maybe thanks to the community contributions. So as I said, this is a thingy community-driven effort. Like I was very surprised about after the initial talk, there are so many people who are interested in this. We are actively work towards unification and a world that both formats can be used for different purposes and enable this multimodal AI host vision. And here are some companies that have been working with us for the past 6 months. Yeah. Thank you very much. That's it.